yesterday, one of the things we talked about was how do you shade, and you look at the equation on the graph. So what happens in number 1, though, is that linear inequality isn't in slope-intercept form. So in order to be able to use the y less than or y greater than, y has to be isolated or by itself. So what we're going to do is manipulate this equation so that we can solve for y. So I'm going to take 4y less than negative 2x. Maybe. Try that pen. And then we're going to divide both sides by 4. So I have negative 2 divided by 4 is negative 8 divided by 4. So now my equation of my line is in slope-intercept form, so I can plot my y-intercept at positive 2. Gotta love it. And then apply my slope of negative 1 over 2. So you're going to go down 1 and over 2. Kind of. So we'll go down 1 over 2. It's just weird. It's like better on the computer than it is on the board. Or we can go up 1 over 2. And then once we have enough points, we can connect or close our graph. What is important, though, is making sure that my graph meets all of my other requirements. So we need to make sure that it is dashed and not solid because it's y less than and not equal to. Okay. That was actually my fault. I didn't turn the zoom off. Now I should be good. And then it's dashed. So you can kind of do what I did. You can draw in a straight line and then erase it. Or you can actually dash it. But I knew my board wouldn't dash. Yes.
So on the test, are we going to have to draw the dashed line, or
yes.
are we going to have this like on the outside dash or dotted?
You mean dash or solid?
Or solid.
I mean, yeah, but you still have to graph it. Like, no, your test will look more like this. Okay. It's literally going to be an equation and a graph. And, like, you got to graph it correctly. And then the next part is the shading. For the shading, I'm going to look at this equation is where y is isolated. So y is less than. So the y values have to be smaller than my graph. Well, if this is the y's are, yes.
How do we go to the left?
So this is y less than. So this is your y-intercept. My y-intercept is at positive 2.
Yeah.
From the y-intercept, are the y values going to be greater up? Yes.
Okay, got it.
So the y values need to be less than shade below.
About the side. So if it's like the less than side, it goes down. Like if it's y less than.
It's below the graph of the line. And it doesn't matter if your line is going down or your line is going up. It's below. Yes. It should be closed. It just my board. It doesn't matter. It doesn't matter though because the line is dashed, so it's kind of like an open circle. because technically that point does not, it's not a solution. But you don't have to draw it as an open point on board just as often. All right, let's look at example number 2. This one is nicer because the y value is isolated. So all I have to do is plot my y-intercept and apply my slope. So in this case, the y-intercept is at positive. So I'm going to put a point at positive 5. What's crazy is it works like perfect in calc. Like, I don't know why your class, it's like period 4 just decides it's going to cry. Point at positive 5, and then my slope is negative 2. So I go down 2 over 1, down 1, down 2 over 1, or you left 1 up. This is greater or equal to, therefore it is solid. Are closed, so the solid guides come from this. Y is greater than, therefore you shade above. Okay. Turn, yes.
Don't we have to shade the lines?
I mean, you shade really close to the line. Like, as long as, so when I'm looking, like, the line itself being shaded doesn't matter. It's kind of understood when you make it solid or dash. So, like, you can get close to it, and obviously you're probably shading a lot more than I am. But, alright. Now, what we're going to do is turn past last night's homework, past the page we didn't do in the homework, and go to the next page. So it says 2-8, Graphing Linear Inequalities, Day 2. So again, if you weren't here yesterday, this little summary should be very helpful for you. The idea is that we are graphing linear inequalities. A linear inequality is basically a graph of a line, but now the solution region has expanded to the shaded area as well. So what you're going to do is graph the line itself, determine if the line is dashed or solid, and you determine that by looking at the y inequality. So if the inequality is less than or greater than, it's dashed. If the inequality is greater than or equal to or less than or equal to, then it is solid. So the equals tells you solid, no equals tells you dash. So it's all about the equal sign being part of the inequality. The shading comes from where the y value is. So if the y value is to the left and less than, you shade below. If the y value is to the left but greater than, you shade above. And then again, you can always pick a test point to determine if your shading is true or false. Yes?
Well, we have to do test points.
Yes. So whether I say a test point or say a solution. So like I might say, pick a point that is a solution. Good morning. Hi, dear. All right. Bye. So yeah, I know her early this month. Doing a lot of fun. All right, so let's look at those 4 examples down at the bottom of that page. So you have y is greater than 3/2 x plus 1. So it's greater than, so that right there tells me that I shade above. And it's not equal to, so it tells me it's dashed. So I'm going to plot a point at +1. I'm going to go up 3 and over 2. I can also go down 3 and left 2. And again, we already determined my line is dashed. So I'm going to draw in a dashed line. And I'm going to shade above. The last thing you want to do is pick a test point to determine if your graph and shading is correct. Now, if I only ask you to pick a test point and not a solution point, the best point to pick, as long as your graph doesn't go through it, is 0, 0. So if I ask you for a test point and not a solution point, the best point to pick is 0, 0. Now in the case of this graph, should 0, 0 come out to be true or false? As long as we've done it correctly. Is 0 bigger than 1? No, so my point is false, which means my shading is correct. And we're happy. And we move on to the next one. Yes?
So if you say you want a solution point, that would be like in our shade.
Exactly. Yes. So if I said, give me a point that is a solution to this inequality, now you have to pick a point in the red shaded region. So you could give me like -3, 0. You could give me -1, 2. You could give me 5, 0, 4, 0, or 0, 5, 0, 4, etc. But like nothing where there's no shading. Okay. Number 2, what's the problem with number 2?
Your y is not isolated.
My y is not isolated, it's in standard form. So we have to isolate the y. So we have 2y is less than or equal to -4x plus 4. Divide everything by 2, and you get y is less than or equal to -2x plus 2. Because again, when you divide everything by 2, it goes to the x stuff and the y stuff. So now we start with our y-intercept. So again, +2. Apply my slope. So we're going to go down 2 and over 1. Or up 2 and left 1. Looking at the inequality, the y is less than. So I shade below, and it's equal to, so it's solid. Yes?
Do you want, like, if we're taking a test, it's like our last test, do you want a certain amount of points on it? Like, you want 5?
Usually 3. So like y-intercept, 1 above, 1 below. But I don't need any more than that. Sometimes I just do more so that I can actually get, that I can get my line correctly. So again, here's my y graph and below. Go ahead, Dylan. I didn't ignore you. I just wanted to.
Yeah, no. I was just confused on like, so like I get in algebra how you get the 2y over there, but like, oh wait, never mind.
Okay. Better? Let's look at the bottom too. have no y-intercept, then you start your graph at 0, 0. And then my slope of this line is perfect. So you go up 3 over 1, down 3, left 1. Is the line going to be solid or dashed? Okay, so we draw in our solid line. And am I going to shade above or below? Above. And in number 4, once again, my y is not on the left. Sometimes people like to move the 2, but if you leave the y on the right, the tricks I teach you don't work. The y value has to be on the left. Has to be in like y equals mx plus b form for those rules at the top of the page to work. So instead of moving the 2, we're going to move the y. So we're going to add y to both sides. And then we're going to subtract x thirds. Don't let x thirds scare you. X divided by 3 is the same as a negative 1/3 in front of the x. It's still your slope. It's still your rise over run. X divided by 3 is the same as negative 1/3 times x. Yes.
I did it a different way, so that's the same answer.
That's fine. What's my y-intercept? 2. And then what is my slope? So you go down 1 and over 3. Or up 1 and left 3. Is my line solid or dashed? Do I shade it above or below? Is 0, 0 a solution? Yes. Is 10, 10 a solution? No. Is negative 10, negative 10 a solution? Yeah. Okay. So that might be some way else I might word it. I might actually give you a point and then ask you, is it a solution or not? If you weren't sure and I gave you the point, how could you be sure if you didn't want to use your graph? Plug it into the equation. And you can plug it into any equation. So like you could plug it back into the original or the form you manipulated. Your homework is the next page. For your homework, though, you guys can skip. Oh wait, your homework is 2 pages. Keep going. Oh, I did the word problems. No. Okay. Your homework is going to be 1 to 6 on the 2-8 Graphing Inequalities, page 2. We're going to do the word problems together more in-depthly.